Okay, in this video I'm going to go over how to solve linear inequalities, and I'm going to express the answer using three different kinds of notation. What I call regular notation, which you might be used to with just the inequality itself, graphical notation, in other words showing you what it looks like on a graph, and then something called interval notation as well. Okay, so let's get started. Here's an example of a linear inequality. So what we want to do is we want to solve for x just like it was an equation. All right, so let's get the x all by itself. Now, when I see this, I notice there's a fraction here, and I'm going to clear the fraction, and I'm going to use a technique called multiplying by 1. Okay, and I'll show you how that works. So the first thing I'm going to do is I'm going to find the denominator for each of the terms that are in the inequality itself, right? So it's a 1, a 1, and a 2. And I want to make them all the same denominator so that I can clear them. So I'm going to multiply this term by 2 over 2. I'm going to multiply this term by 2 over 2 as well. And when I do that, each of my denominators now, and let me just go ahead and rewrite this. Now remember, multiplying by 1 doesn't change the quantity of the term, but it does actually change the form or the look of the term itself. But I wanted to try to get all the terms to have the same denominator. So what I'm going to end up with here is a negative 4x over 2 minus 2 over 2, which is less than or equal to 1 over 2. Now, by creating the same denominator in every single one, I'm able to get rid of them, right? Which leaves me now with a negative 4x minus 2 is less than or equal to 1. This is an equivalent term to the first equation, or first inequality rather, that I have, and it's a little bit easier to solve, okay, because it's all whole numbers. The next thing I'm going to do is I'm going to add 2 to both sides. Let me just go ahead and do that. I get a negative 4x is less than or equal to 3, and I'm going to divide by the negative 4, and remember that when you divide an inequality by a negative number, you have to turn the direction or flip the direction of the inequality itself. So now I'm going to get x is greater than or equal to 3 over negative 4, or just a negative 3/4. Okay, so now that would be what I would call regular notation. It's just the x is greater than or equal to a negative 3/4. Graphically, what does that look like? Let's draw a number line. Okay, there's my number line. I'm going to put the 0 there as a reference point. I'm going to put a negative 1 there. And I see that it's a negative 3/4. So I'm just going to go right here. Since it's equal to, I'm just going to approximate it. I'm going to fill it in too, since it's an equal sign. And I'm going to follow the direction of the arrow to draw my line. Okay, so basically what I'm saying is at any point on this one number line, since there's only one variable, that just means I need one axis, or the x-axis is also just the number line. Now that's important. The x-axis is also just called the number line, right? And that would be my graphic representation of the answer. Now just to check it, let me just choose any number that I've put in here that's been shaded, and it should work in the original problem, right? So let me just do a quick check. All right, let me just choose 0, because 0 would be a really easy one to use. So I'm going to say negative 2, I'm going to replace the x with 0, minus 1 is less than or equal to 1/2. Let's just see if that's true, okay? Negative 2 times 0 is 0 minus 1. That just gives me negative 1. Is negative 1 indeed less than or equal to a 1/2? And it is, isn't it? So I know that this answer is probably correct. Now, I'm not done yet, because I remember I also wanted to do this in interval notation. And remember how you do interval notation? I'll call this the graphic notation. I'll call this the regular notation. And then finally, I'm going to do the interval notation down here. Oops, interval, not internal. interval notation. The way you do that is you start from the left side of the graph itself, and I see that it's -3/4, so I'm going to put down -3/4. Then I'm going to go to the far right-hand side of the graph, and I see that it's an infinity, so I'm going to put a comma, positive infinity. Now I go back and put in the parentheses or the brackets. Since I'm including -3/4, I'm going to put in a bracket. And remember that infinities just go on forever, so there's no end point per se. I'm just going to put in the parentheses. Okay, so that would be the answer in interval notation. Here's the answer in graphic notation. Here's the answer in regular notation. So that's the first one. Let me just try one more example for you. Here we go. So here's my problem. Notice that I've got the x on both sides of the inequality itself. So we're going to start the same thing. And also I see a bunch of different types of denominators, right? I've got a 2, a 1, and a 3. Now, be careful with this 1/2 x. Some people don't realize that really is just the same thing as saying 1x, which I don't need to put the 1 over 2. That x is actually over the 2, okay? So I'm just saying half an x, and that's just another way of saying half an x. Okay, so what would be the common denominator for all of these denominators that I have here? And an easy way to do that is just to multiply them. So 2 times 1 times 3 is 6. So the common denominator here could be 6. So which means I'm going to multiply this denominator by 3 over 3, so now I have 6. I'm going to multiply this denominator by 6 over 6, because now I'll have 6 here. And I'm going to multiply this denominator by 2 over 2, because again, now I have 6. And what I've done is I've just made all of these denominators exactly the same. And now let's just go ahead and rewrite the numerators. I have 3x is greater than or equal to 6x plus 4. And again, whole numbers just seem to be a little bit easier to deal with than fractions. Let's get all the x's on the same side. I'm going to subtract 6x from both sides. That's going to give me a -3x is greater than or equal to 4. I'm going to divide by a -3. That's going to give me x. And again, remember, when you divide by a negative, you have to flip the direction of the sign. Is less than or equal to -4 over 3. So here's my regular notation, isn't it? Just like what we did in the last problem. Graphically, what does that look like? Here's my number line. Again, one variable means one axis, right? So I'm going to again put in a 0 as my reference. I'm going to go 1, -1, -2, +1. So -4/3 is a little bit greater than 1. And again, I'm going to go right about there. It doesn't really make any difference where you put it as long as you label it, right? There is an equal sign, so I'm going to fill it in. And I'm going to follow the direction of the arrow, and that's in that direction here. So again, that means that graphically, anything shaded should work in the problem. So here's my graphic notation. And finally, let's just go ahead and use the interval notation now. And remember, interval notation says you start in the far left of the graph, and it's a negative infinity, right? Because it just keeps on going. Then you put a comma, then you go to the far right of the graph, and it looks like it's a -4 over 3. Now let's go back and put in the parentheses or the brackets. Infinities always have a parentheses because there's no hard spot. It doesn't stop at any one point, it just keeps on going, and that's what that parentheses represents. However, on the right-hand side, it does stop and include -4/3, so I'm going to write it like that. Okay, I hope that was helpful to you. Again, if to check it, just choose any point in here, plug it in, and you'll see that it will work fine. Okay,